All right, our next transformation that we're going to look at this week is rotations on the coordinate plane. Remember that a rotation is a turn. So far we've looked at slides and flips, we looked at our translations and our reflections. Now we're going to take a look at some rotations. You're using the same foldable you used for your translations and reflections page. And we're going to turn first to our rotations. We're going to do two examples. We're going to do one example of a 90-degree rotation and one example of a 180-degree rotation. All right, this year you will be asked to do 4 different kinds of rotations. You'll have a rotation of 90 degrees, 180 degrees, 270 degrees, or 360 degrees. Remember that a circle has 360 degrees, so we're going to rotate this 90 degrees, which is like 1/4 of a circle. So we're going to rotate this 1/4, and we're asked to rotate the graph of this quadrilateral 90 degrees clockwise about the origin. You need to know which way is clockwise or counterclockwise. Thinking about a clock, remember a clock goes to the right as the hands move. So when we turn clockwise, we're going to go to the right 90 degrees. Now, when we do this, we're going to write the coordinates of the original and the new figure or the image. Let's go ahead and write down our points for A, B, C, and D. Point A is at 0, 4. Point B is at 3, 5. Point C is at 3, 1. And point D is at the origin 0, 0. That's going to be the easiest one to rotate. Now, when we rotate or turn this, it's like turning the whole graph 90 degrees. If I were to turn the graph 90 degrees, it's going to end up in our quadrant number 4. So here we go. Point D, if I rotate point D 90 degrees, it just ends up right back where it was. So that's the very quickest and easiest one. The image of D is at 0, 0. Okay, let's go look at point A next. Now, if I turn A 90 degrees, thinking about a clock, a fourth of a clock, right now it is pointing straight up. If I turn 1/4 of the circle, point A is going to end up on the x-axis. So this point A moves over to that point right there. It was at 0, 4. Now it's moving over here. The image of point A is now at 4, 0. Now, point B is going to turn. This time it's going to be below the x-axis. It's moving down, so we're turning it around. And it's going to be at the ordered pair. The image of B is going to be at the ordered pair 5, -3. Let me label these. That's the image of A and the image of B. Now, notice that the image of B is still kind of over 1 and down 3 away from the B value. It's still the same distance away from A that it started. And then point C is going to rotate. It was in line with B, so it's still going to be in line with point B, and it's moving over here to this point. This is C prime, and the image of C is now at the ordered pair 1, -3. We're going to connect all of these points to make our quadrilateral. So this has turned 90 degrees, or turned 1/4 of the circle. Kind of looks like it's starting to make a windmill to me. Now, looking at our ordered pairs, when we rotate 90 degrees, notice that point A was at 0, 4. It flopped to 4, 0. Point B was at 3, 5. They switched places, and it's 5, -3. Point C was at 3, 1. They, X and Y, have switched places, and they're at 1, -3. And then D switched places, and it's now 0, 0. Now, the two that I want to focus on are point B and C because they don't have zeros in them. Our X and Y switched places, but then what happened to the Y values? They changed signs. So there are two things that happen when we rotate 90 degrees. The two things that happen are the X and Y switch places. Write this down, please. The X and Y switch places, and then after the x and y have switched places, the y value changes sign. It's kind of like those reflections. When we reflected, we had our x or y values changing signs. So this time the x and y switch places and the y value changes signs. All right, let's look at example 6. We have triangle ABC has vertices at 1, 0, 3, 3, and 5, 0. We're going to rotate this triangle 180 degrees about the origin. Now, they don't tell us if it's clockwise or counterclockwise, because when you turn 180 degrees, it just means to turn it completely around. We're going to write the coordinates of the new and original figure. So let's go ahead and write down our A, B, and C coordinates. The coordinates of point A are at 1, 0. Coordinates of point B are at 3, 3. And the coordinates of point C are at 5, 0. Now, a lot of times if you watch skateboarding or skiing or BMX, when they're doing tricks, they'll talk about they just did a 180. A 180 is a rotation halfway around. So we're going to take this and we're going to turn it halfway around a circle. It stays the same distance from the origin. Now, if we take point A and we move it 180 degrees, it's going to go around to the other side, and it's going to end up right here at this point. This point we're going to label A prime, and its ordered pair is -1, 0. Taking a look at point B, this is going to make another 180 degree rotation. As we rotate this around the origin, it's going to be the same distance away that it started. If we look at this, it is 3 units diagonally away from the origin, so we're going to go 3 units to the opposite diagonal for our 180 degree rotation. And it's going to be right here. This is the image of B. That ordered pair is at -3, -3. And our last one, point C, is going to rotate all the way to this side. It was at 5, 0. Now this point C is going to be, or the image of C, is going to be at -5, 0. Now we're going to connect our points, the image of A, B, and C. This rotation is the same size, so our triangle is the same size, but it has turned upside down. So it preserves the size, it's congruent, but it does not have the same orientation. Now, if you take a look at the ordered pairs, we had 1, 0, that changed to -1, 0. We had 3, 3, that changed to -3, 3. And then we had 5, 0, that changed to -5, 0. Notice for all of these, the change in our ordered pairs were the sign of each of the x or y values changed. Now the 0 can't change sign because 0 is not positive or negative. But when you have a 180 degree rotation, you switch the sign of x and y. They didn't switch places, but the sign of x and y both changed from positive to negative. Alright, make sure you have this ready for class on Thursday. We're going to be working on some rotations around the coordinate plane, and then we're going to move next week into dilation. So we are almost done with 2 weeks left to go.